Ever dreamt of napping your way to the stars? Guess what? It's not as bizarre as it sounds. We're set to unravel the intriguing possibility of human hibernation in space, a concept that could transform interstellar travel as we know it. Stay tuned till the end as we expose how this fascinating concept could redefine our future in the cosmos. This is not some far-fetched sci-fi flick, but a dream that's inching closer to reality. Space colonization, a concept buzzing through scientific circles for years, faces a significant challenge: the unfathomable distances between stars and planetary systems. Astronomical units separate us from even the nearest celestial bodies, making interstellar journeys a bit more complex than finding the nearest charging station for your Tesla. Now, humanity isn't one to back down from a challenge, are we? As we've been tackling the tech problems, we're also bracing ourselves for the economic hurdles and biological speed bumps that stand between us and our celestial dreams. Scientists have been poking around the mechanisms that trigger different survival modes, leading to exciting discoveries of ways to induce this deep sleep state in non-hibernating species like mice and monkeys. If it's working for them, why not us, right? You might be wondering, what on earth, or rather off it, is human hibernation? It's all a game of matching the right neurotransmitters in our brains to kickstart this state of prolonged torpor or hibernation. So, onto the million-dollar question: can humans take a cue from bears and hibernate too? Now, before you conjure images of people tucked away in cozy cocoons, let's consider what we're really talking about here. It's not just taking a long nap to get to Mars. This is about opening new frontiers in healthcare right here on Earth. From beating cancer to staving off Alzheimer's, reducing stroke damage to slowing aging, and even better ways of preserving organs. Talk about a sci-fi fan's dream coming true. But let's get real. Human hibernation is a hazy mystery. We're all familiar with those sci-fi classics, right? You know, the ones where humans are tucked away in pods, motionless and seemingly unconscious. This state of deep slumber, often referred to as suspended animation, or the even chillier sounding cryosleep, seems to involve temperatures that would have even a polar bear reaching for a blanket. But here's the plot twist. Real hibernation isn't about turning people into human popsicles. Nope, we've got a lot to learn from our animal friends who, believe it or not, can survive in sub-zero temperatures. They've mastered the art of avoiding ice crystal formation in their cells. Impressive, right? But we humans aim for something less freezing. We're just looking to slow our metabolic rate down, ideally without any cold at all. So what would it feel like to hibernate? Would hibernating humans dream about idyllic summer days or the replay of favorite memories? No one can be certain yet. At a research lab in Oxford, scientists are striving to demystify the hibernation process and its impacts on the brain. A state of inactivity so deep it slows down your metabolism, reducing energy use to the bare minimum. It's like pressing the pause button on life. And who's the master of the remote? Neurotransmitters in the brain. Yep, these brainy molecules might hold the secret to triggering this long snooze. Or, as the science geeks call it, torpor. Given the significant bodily slowdown hibernation induces, it is also expected to influence senses and behaviors. It's speculated that hibernation could effectively create a sort of time warp, with time seemingly standing still or moving at an ultra-slow pace. But why would we want to play around with cell time? Well, let's talk space travel. Picture this: a long trip to a remote planet. You're stuck in a spacecraft with the same faces, the same views, except when you're lucky to pass by a star or asteroid, and a limited supply of oxygen, water, and food. Sounds exciting, but also quite taxing, right? Not to mention the possibility that this might be a one-way ticket. Hibernation could be a game changer, a form of time travel allowing us to skip the boring parts and wake up when the action begins. Sounds like the stuff of dreams, right? But it's already happening in the wild. Some animals hibernate through seasons, like the ground squirrel, who might not even know what winter feels like. Can you imagine skipping the whole winter and hopping from one summer to the next while adding months to your life? Sign me up. Here's a juicy tidbit for you. Dropping the metabolic rates of astronauts to about 25 to 30% during journeys to places like Mars could save us a boatload of supplies. from food to oxygen cylinders and even space. Talk about packing light. But when will this cosmic lullaby become a reality? According to Jennifer Ngoan from the European Space Agency's Human and Robotic Exploration team, this could be a reality by the mid-2030s, given the right amount of funding. She further said, "Of course, we need to fine-tune everything before we can apply it to humans, but I would say that 10 years is a realistic timeline. And it's not just pure talk. In the labs, rats are having a taste of this hibernation lark. These little creatures are helping scientists understand if it's feasible to put non-hibernating species into a state of torpor and, more importantly, bring them safely back to the world of the conscious. To pull this off, researchers treat the rats to a bit of a spa experience. It involves some quality time in reduced daylight, a hearty meal followed by a fast, and a good dose of a certain neurotransmitter drug to kickstart the hibernation party. The hiccup? Hibernation isn't a one-hit wonder. It requires a consistent high-level supply of the neurotransmitter to keep the rats in the hibernation state. According to Jürgen Berita-Hahn from the hibernation research team at the European Space Agency, this could potentially be a problem in the long run. So how will these hibernating astronauts get transported to outer space? The conditions for hibernating astronauts would be carefully controlled to promote a prolonged state of torpor. Comfortable sleeping pods would be designed to maintain the perfect environment for hibernation. Each pod would be a climate-controlled dream, with temperatures lower than 10 degrees Celsius or 50 degrees Fahrenheit. Humidity perfectly balanced to keep astronauts from drying out like desert lizards. And let's not forget about the mood lighting, or rather lack thereof. It'd be as dark as a moonless night to facilitate a true hibernation state. But it's not just about the comfy slumber. Safety matters too. Radiation is no joke in outer space, but we've got it covered. The pods could be wrapped up in a cocoon of water containers, excellent for fending off those pesky cosmic rays. Keeping tabs on our snoozing spacefarers, all in a day's work with high-tech monitoring systems to track vital signs. If anything goes haywire, ground control can gently rouse them from their slumber. So think of these hibernation pods as cozy, self-regulated, and safer spaces, all designed to make the space dream a reality. Now, before you get too excited, scientists have some homework to do. They need to ensure hibernation doesn't come with a nasty hangover. Hibernation, you see, isn't all sweet dreams and snores. It could cause some worrying changes in brain proteins, changes that are eerily similar to those seen in Alzheimer's disease. On top of that, there's some concern about the weakening of synaptic connections. You know, those little chatterboxes that let our neurons talk to each other. But don't start hitting the panic button just yet. It seems there's a plot twist. The effects seen during hibernation aren't in the final chapter. Instead, they seem to reverse once the animals come out of their slumber. If that doesn't show the astounding resilience and adaptability of the brain, then what does? The unveiling of this fantastic piece of the puzzle might have bigger implications. According to Vladislav Vyazovsky, it could open a whole new world of possibilities for tackling neurodegenerative diseases in humans. So as we peer into this intriguing new frontier, the plot is thickening, and human hibernation might be closer than we think. But what about the potential cliffhangers? How will our brave space travelers handle emergencies mid-hibernation? Fear not, it appears android robots will be waiting in the wings, ready to wake the crew if the plot takes an unexpected turn. This way, the exploration of space, vast and thrilling as it may be, will not pose a risk of radiation sickness upon return. So, with the promising advances in medical science and artificial intelligence, a future where interstellar travel is as easy as pressing the snooze button doesn't seem that far-fetched, does it? Brace yourself for a time when a journey to galaxies far, far away is just a good night's sleep away. Now that's what I call a dream come true.